In this session, we are going to see the techniques of function calls in C. So in normal C program, there are a couple of ways in which you can call a function. So there are two ways. One is call by value, the other one is call by reference. So you can make a function call through call by value or through call by reference. So in call by value, what we do is we try to pass the value of the variable by calling function to the called function. So basically, you know the difference between a calling function and you know the difference between the called function. So what happens here is in a calling function, let's say for example, I'm trying to make a function call. So for this particular function, there are two input requirements, or there are two input arguments that this particular function needs or requires. So what happens is the value is getting passed through the input arguments, that is A and B. Okay, so basically what we do is we try to pass the value in terms of variable, or sometimes we can directly pass the value without the variables as well. We'll see with the help of some examples later. But as of now, we just understand that call by value, we are trying to pass the value of the variable from the calling function to the called function. And in call by reference, we try to pass the address of the variable from the calling function to the called function. So basically the difference is we try to indicate the address of the particular variable, so that what happens is in call by reference, the variable, in the function definition, the address will be referred and then the value that is present in the address will be processed. So this is a basic difference between call by value and call by reference. So I repeat, in call by value, we are just simply passing the value of the variable directly from the calling function to the called function. In the call by reference, what we do is we try to pass the address of the variable from the calling function to the called function. And if you are still not clear with what is the difference between the calling function and the called function, please try to refer my previous videos. So I'm directly moving to the simple example for function call by value. So before we move to the examples, first let us try to understand what happens in function call by value. So actually in the called function, what it does is it is trying to create a new variable to store the value of arguments passed to it. So whatever value is getting passed in the name of the argument from the calling function, the called function will try to create new variables, and these variables are called as the formal parameters. So what happens is a copy of the actual argument is being taken by the called function in order to perform the logical task, and any changes in the formal parameters will not impact the actual arguments. So we'll see an example so that you can clearly understand this concept further. So what happens here is I'm trying to declare a function, and the name of the function is multiplication, and it has a return type of integer, and there are two input arguments, that is A and B, and these input arguments are of integer data type. Now I'm writing the main definition for my main function. So I declared three variables of integer data type. X has got the value 10 and Y has got the value 20, and Z is simply declared without any assignment. So immediately what happens is a memory space is being created for the variable X, Y and Z, and the value is being allotted for X and Y in the corresponding memory location, and Z is, since it is only declared, it has got no value in the memory location. Now what happens is I'm trying to execute the next statement. The next statement has got assignment statement, that is Z value is equal to a function call. So here what happens is the function is getting called, so my main function becomes the calling function, and multiplication of X and Y, that becomes a called function. So immediately the control passes to the definition of the particular function, that is multiplication. So as I told you, we have already discussed a lot about the declaration, function call, as well as the function definition. So I'm directly moving to the function definition. So what happens is during this particular statement, a function is getting called, and immediately the compiler passes the control to the function definition. So here goes my definition. Now what happens is, before the definition, what happens is a memory space has been created for this particular function. As I told you, X carries the value 10 and Y carries the value 20, and this value is getting passed to the function definition. So X and Y, they are going to act as the actual parameter, and A and B, they are going to act as a formal parameter. Always remember, in function, the formal parameter will execute the logical task. So A value becomes A has got the value 10 and B has got the value 20. So immediately when this particular function definition is getting called, what happens is a memory space has been created for this particular function, and the copy of the actual arguments is getting takes place. So what happens is x value is being taken a copy in the name of the variable a, and the y value is taken a copy in the name of the variable b. So new variables are created in the name of a and b for the values that are getting passed through the variables x and y. So a takes a value of x, that is 10, and b takes a value of y, that is 20, and both the variables are being created with some specific memory location. Now what happens is I am trying to execute the definition of my function. So here I have a variable that is c that is getting declared as a first statement in my function definition. So immediately what happens is a memory space has been created for c, and next thing is the c value is getting assigned to the multiplication value of a and b. So the next statement says that c is equal to a star b. So what happens is a value and the b value both are getting multiplied, and that value is getting assigned to the variable that is c. So in the memory location of 2007 is the memory location, and the memory location has been identified by the variable that is c. So the result of a into b, that is 10 into 20, 200, is getting assigned to the value that is c. Now in the next statement the value c is getting returned. So what value is present in the memory location of c? So 200 is the value that is getting returned from this particular function. So this particular function call will return me the value that is 200, and z is getting assigned to that value 200. So in my memory location now what happens is 200 is getting allocated, and in the very next statement I am trying to print the value of z. So in my output I will be getting the value that is 200. So here x, y and z, they will act as the actual parameter, and a and b will act as formal parameter. So a, b, c will act as the formal parameters, and x and y will act as the actual parameter. So actual parameter in the sense the function, whatever arguments that we are going to use during the function call, they are called as actual parameters, and whatever arguments that we are going to use in the, whatever parameters that we are going to use in the function definition to execute the logical task, they are called as the formal parameter. So moving on further, we will just try to identify a very major difference. In case of the actual parameter that is getting passed during a function call, it will not have any impact on the formal parameter. So let's say for example I write a function declaration like this, that is modifies the name of the function, and the return type of this particular function is integer, and we try to pass one input argument that is of integer data type. And now I'm starting writing my main function. So in my main function what I do is I create two variables, that is x and z, and x has been assigned to a value that is 10. So after executing this particular statement, that is int x is equal to 10 and comma z value. So what happens is memory space has been created for the variable x, and 10 has been present in that particular, the value 10 is getting assigned in that particular memory location in the name of the variable x. And since we have declared only z, so a memory space is being reserved for the variable that is z. So in the next statement I have a assignment statement, that is z value is equal to modify of x. So modify of x indicates about a function call. So we try to pass one input argument to the function modify, and that particular value is getting passed in the variable name through x. So in my function definition I have another variable that is a as a formal parameter or as a formal argument. So throughout the session parameter argument both has the same meaning. So whatever term that I'm going to use, whether it is argument or parameter, both are same. So here I have a separate I have a formal parameter that is a. So a copy of the variable x is being created. So whatever value that x is going to hold, that value copy is being created through the formal parameter that is a. So my compiler, what it does is, here I'm going to create another memory space for the particular value that is 10 in the name of the formal parameter that is a. So in my function definition what happens is I have a separate statement, that is a value equal to a plus 10. So now what happens is, this is an assignment statement. So the assignment statement will be executed from right to left. So a value has already got the value that is 10, and you are again adding 10 more value to the a value. So a value becomes 20 now. So in the same memory location a value becomes 20, and this particular value is getting returned. So both, as I told you, your a value will act as a formal argument or as a formal parameter. Now I'm trying to return the value of a to this particular function call. So modify of x will return me the value that is 20 to this particular statement. So you have the complete value that is 20 in this particular function call, and this 20 is getting assigned to the variable that is z. Now I'm trying to print the value of x. So there is no change in my actual argument, that is x, and you can see the changes that lies only in the formal argument. So x is the original argument that is getting passed. Okay, so that value is not getting changed. The value of x is not getting changed, but the copy of the value of x that lies in the formal parameter a gets changed to 20. So that is one major thing in the function call by value. That is, your actual argument will not get modified by the formal parameter, whereas the formal parameter will get modified before the function, after the function call. It may get modified after the function call. So this is one example where we are trying to modify the formal parameter, and where the actual parameter is not getting changed. So your actual parameter, that is x, is not getting changed, whereas your formal parameter gets changed to the value of 20. So moving on further, we'll see the when we are supposed to use the function call by value. So one thing is, your function call, it is going to create a new variable of the same data type as the arguments that are getting passed to it, and whatever values are getting copied. Okay, so what happens is, from the actual arguments we are going to make a copy through the formal arguments, and your actual arguments are not modified or affected through your formal arguments. So next we are going to see when we are supposed to make use of the function call by value. So whenever you are not going to modify your actual argument, then you can go for the function call by value. And if there is going to be any temporary modification through the formal parameter, or not any permanent change is going to happen in your actual parameter, then you can go for the function call by value. So what are the advantages of going for the function call by value? So basically, your argument that you are trying to pass through the function call, it may be a variable, or it may be a value, or it may be an expression. So for example, here we have just passed the value of we have just passed the value of 10 through the variable x. So instead of having a variable, I can even directly pass the value of 10 over here, or I can even give an expression 10 into 5 or 2 into 4, like that. I can give the expression as well. So basically, whenever you're trying to pass the argument can be a variable or a value or an expression. So what is the disadvantage of function call by value? The disadvantage of function call by value is that it takes a copy, so it takes additional storage space to copy the particular value, and it takes additional time in order to compute the particular logical task. So this is one of the disadvantage when you go for the function call by value. So to avoid this, we are going for the call by reference. So as I told you, in call by reference, if you want to modify the actual argument value, then we can pass the reference of the argument to the function call. So here, when I say about the reference, it speaks about the address of the argument. So any changes in the function is visible in the actual argument in the calling function. So once we touch the particular address, so what happens is, any changes that are going to happen to that particular value will take place directly in the address itself. So there is no scope for copying the value of the actual argument. So you have to place an asterisk before the argument in the called function. So we'll see an example. So the called function has to make use of a reference. So for reference, we are making use of the asterisk symbol. So in my main function definition, what I have done is I have declared two integer variables, that is x and z. X has got the value 10 and z is simply declared. So what happens is, a memory space has been created for the variable x, and it is holding the value that is 10 in the memory location. And since z is simply declared, it has got a memory space reserved for the variable z, and it has not got any value. So in the next statement, what I have done is I have just declare, I used an assignment statement. I'm calling the function that is modify. So basically, as I told you, in call by reference, we have to pass the address of the argument. So the argument that we are passing is x. So the address of the variable x is getting passed to the function call. So immediately what happens is, the control passes to my function definition. So in my function definition, I'm making use of a pointer variable a. So what happens is, a is going to retrieve the address of x, that is 1001. And so since I'm going to use the dereference, that is a unary operator, so this unary operator star will actually try to retrieve the value that is present in the memory location. So whenever for a pointer variable, if you are trying to give that is the asterisk symbol before the pointer variable, it will try to refer the memory location where it is getting pointed to, and it will try to retrieve the value that is present in that particular memory location. So if we simply try to access, if we simply try to put the value that is a, it will have the address of the variable that is x, because x is the address of x is getting passed as an input argument to this particular function definition. So what happens here is star a. So the star a indicates about the value that is present in the memory location 1001. So directly the function definition will look for the memory location and the value that is present in the corresponding memory location. So the first line of my definition states about, okay, it's assignment statement. It says that the value that is present in the memory location, that is 1001. So the value that is present is actually 10. So star a will point to the value that is 10, and where this 10 is present, this 10 is present in the memory location of x. So memory location of x is going to have, that is 1001, and using the dereference concept, that is if I'm going to apply the unary operator star on this particular memory location, I can retrieve the value that is present in the corresponding memory location, that is 10. Now what happens is, with this value that is 10, I'm trying to add the value 10 so that it becomes 20 now. So star a becomes 20 now, and this 20 is getting assigned to the pointer variable that is star a. So what happens is, in the memory location 1001, the value is getting updated as, so what happens is, in the memory location of x, the value 20 is getting updated. So the address of the particular variable x, so 1001 is getting updated with the value that is 20 directly. So here we are not going to take any copy of the original argument, that is x. So instead what we are going to do is, we are going to touch the memory location, and whatever computation is going to happen, that will directly happen in the memory location itself. So this is the concept of call by reference. So what happens next is, I'm trying to return the value of star a. So star a is holding the value that is 20. So 20 will be returned to this through this particular function call. So 20 is getting assigned to the value that is z, and I'm trying to print the value of x and z in the corresponding statement. So 20 will be getting printed. So one basic thing that you have to see here is, initially before the function call, the original value was 10. That is the actual argument value was 10, and after the function call, the actual argument makes, whatever changes that we have done through the particular argument, there is a formal argument in the function definition, it changes the actual argument directly in the function call itself. So what happens here is, the basic difference is, when we are trying to make use of the call by reference, we are trying to access the value through the memory location, and whatever changes or whatever computation that we are going to do on the particular arguments or on the particular actual arguments will be reflected in the actual argument location itself. So that is a very important concept in the call by reference. So one advantage is that it has got more time and space efficiency, because you are not going to make a copy of the actual argument, and of course when you are trying to make a copy of the actual argument, you take some time to process that. Okay, that time is also saved in the function called by reference. So the called function, it is going to change the value, and that changes is going to reflect, or it is going to be seen in the calling function as well. And whenever you want to return multiple values through the passing arguments, that can be done with the help of the call by reference. So one major disadvantage is that it is very difficult to tell whether the argument that you are trying to pass through the function call is meant for input or output, or for both. So please try to refer this video once again, and if you have any queries, you can post it in the comment section. Thank you.